Dear viewers, welcome to another video on control charts. In the series of control chart videos, we have already seen control charts for continuous or variable data. In that order, we have seen IMR chart, individual moving range chart, X bar R chart, and X bar S chart. And we have also seen videos on attribute control charts like P chart, NP chart, U chart, and C chart. These are some of the commonly used charts, so these videos are already posted. In today's video, we are going to use or we are going to see a chart which is not that commonly used. ZMR or ZMR depends on how we pronounce this alphabet. ZMR chart is the chart that we are going to see in today's video. Let's get into this video. As I was explaining, the continuous data control charts are IMR, X bar R, and X bar S. ZMR is also a continuous data variable chart. It has some of similarities with IMR chart and also some uniqueness which is not part of IMR chart but specific or unique about ZMR chart or ZMR chart. So in this video, let's understand the commonalities and also understand the difference between IMR chart and ZMR chart. To start with, I have created a table to give you a comparison, and I also created a small example to tell you the crux of what is a ZMR chart. Then I will take you through how the chart need to be drawn in Minitab and how the chart need to be drawn in Excel file. First, let's understand the comparison of IMR and ZMR. So IMR stands for individual moving range chart, where it is drawn to measure the variability of a measured value, a variable data. The I chart gives you the closeness of individual data points to its central tendency, and MR chart tells you how much is the variation or range of two consecutive data points. So both your I chart and MR chart are drawn on absolute values of the measured value, the individual values of the measured value, and the moving range of the measured value, and their corresponding upper and lower control limit formulas are given here. So this is about IMR chart. On the other hand, ZMR chart or ZMR chart is drawn again for continuous or variable data only, again for data collected in the form of one after the other, not in the form of subgroup. Like how IMR chart data is collected one by one. Similarly, in ZMR chart also data is collected one by one, but the only difference is ZMR chart is drawn for short production runs. What do we mean by short production run? Let's say in a stamping process, for the first 1 hour, I set the machine and do stamping for a particular part number. Then I change the machine, change the setting and do stamping for some other part number. Maybe for common audience who do not understand what is a stamping process, for us to easily understand the coins that we use, like how our currency note, the coins that we use, the 1 rupee, 2 rupee coin, it is stamped from a metal film, or they call it as tape. So there is a metal tape from which it is stamped, and then it goes through polishing, shining, various processes, and it comes to us as a coin. And we all know definitely not all our coins will have same thickness. 1 rupee coin will have a different thickness, 2 rupee coin may have a different thickness, 5 rupee coin will have a different thickness, and 10 rupee coin will have a different thickness. Maybe for 3 days, 4 days, if I produce only 10 rupee coins, then I produce only 2 rupee coins, I can go ahead and use IMR chart. Whereas first 1 hour, I produce only 1 rupee coins, I change the setting of the machine. Next 30 minutes, I produce 2 rupee coins, change the setting of the machine. Next 2 hours, I produce 5 rupee coins. What I am doing? I am doing short production run. Same machine, same operator, but my part number changes. So what will happen? Definitely the measuring parameter, in this case, which is thickness, is not going to be the same for 1 rupee, 2 rupee and 5 rupee coin. Obviously the thickness will change. So I cannot plot it in the same control chart like how I do it in IMR chart. So what I have to do, I have to now have a different chart. And what is the different chart? The different chart is ZMR or ZMR chart. Now how this is different from IMR? Here the chart is not drawn on the measured value. Instead, the measured value get converted into the corresponding Z score or Z table value. What is corresponding Z score or Z table value? I'll explain. It have a formula. What is the formula? The formula says Z conversion formula is let me go to the formula again. Z conversion formula is absolute value, which is X, minus Z bar divided by standard deviation of the value. So what are we doing here? In this example, the average of the value is 220. The value for which we want to find z score is 175. So how do we calculate the z score? The z score is calculated by absolute value, which is x, minus average of x, which is x bar, divided by standard deviation of the process, which is 24. So what we are doing, we are saying 175 is 1.8 times of standard deviation away from its average. So what are we doing? We are converting the absolute value into z score, and z score is nothing but how far is your individual data point away from its mean in terms of its standard deviation, right? So the z score will simply say your data point is 1.8 times away from its mean, 1.8 times of standard deviation away from its mean. It is minus 1.5 1.8 times of standard deviation away from its mean. If I have a value like 250, then I would say 250 minus 220 divided by 25, then it will say it is plus 1.2 or 1.1 times away from its standard deviation, so, away from the mean in terms of its standard deviation. So what are we doing? By converting the actual value into z score, we are converting the measured value into a standard z score. Just to give you an example, here are height of some students, and these are students in 11th standard, and these are students in 5th standard, and we all know students in 11th standard will definitely be much taller, and students in 5th standard will have a different height range that will be nowhere comparable to student in the 11th standard. Their heights are different. Now if I see these values, these are not comparable values, these are not comparable values. But what I'm going to do, I'm going to convert this value into z score. So what I will do, first I will calculate average of these values. So average of 11th standard students value. Then what I do, I calculate standard deviation of 11th standard students height. So here is the average and here is the standard deviation. And when I do this, then what I do, I say is equal to absolute value minus average. So just to make sure I can copy paste the formula, I'm going to freeze this, and then I say this value divided by the standard deviation. Again, in order to copy paste, I'm going to freeze this value. So I'm going to press F4. So 152.5 centimeter is minus 1.47 times of standard deviation away from, minus 1.47 times of standard deviation away from its average, which is 159.35. Now what I can do, I can copy paste this value. Some of the data points are minus or in negative units away from the average, some of the data points are positive units away from the average. So what we are doing is we are converting the absolute value into its corresponding z scores. And what we do now, we will do the same thing for students in the 5th standard. So I say average then I say standard deviation, now I say is equal to this value minus this value. Again, for the sake of copy pasting it, I'm going to apply the star symbol, sorry, dollar symbol, to freeze the cell, divided by standard deviation. Again, for the sake of copy pasting the formula, I am applying standard deviation. Now I copy paste this for all the cells. So friends, if you see these two columns, so this is the corresponding z score. If you see, the absolute values are not comparable, whereas the corresponding z scores are comparable. Why? Because we are converting the absolute value into z score, and z score is simply how far is your individual data point away from its average in terms of standard deviation. So the z scores, even though the absolute values are not comparable, the corresponding z scores will be comparable. Now what we can do, now even though on a very short run I have 3 production runs, one for 2 rupee coin, one for 1 rupee coin, one for 5 rupee coin, their thickness will definitely be different, but those thickness can be compared into z scores, and for that z score I can plot a Z chart and the moving range for the Z values. Then what will happen is I will be able to compare all the three different metrics, thickness of 1 rupee coin, 2 rupee coin and 5 rupee coin in the same chart. Why? Because what we are discussing is statistical process control. Is the process good enough to produce different part numbers which is generally produced from that particular process? The machine is same, the operator is same, so whether the process is good enough. So that is what we are going to measure. So this chart helps us to measure different kind of measurements, short production runs on the same machine. Still we will be able to compare it in a chart, and that is the unique feature of ZMR chart or ZMR chart. And what are the formulas? The formulas are very simple. The formula here is convert your original data into Z scores, and once you convert them into Z score, we all know for a standard Z table the average will be 0 and the standard deviation will be 1. So your Z table, your Z graph average will be 0 and USL will be always plus 3 and LSL will be always minus 3. Why? Because absolute values are getting converted into Z scores and we are going to draw chart only for Z score. So always your USL and LSL will be plus 3 and minus 3 and your center line will always be 0. Why? Because for a standard normal Z table the average will be 0 and standard deviation will be 1. And similarly for the moving range, what are we doing? We are drawing moving range chart for the consecutive Z value moving range, not for the absolute value moving range. For example, in this case the absolute value moving range will be the difference between these two data points, but the Z value moving range will be difference between these two data points. So that is the value that we are going to draw, and for that also the formula is very similar to IMR chart. The center line will be the average of your moving ranges and your upper control limit will be D4 times of your moving range average and lower control limit will be D3 times of the moving range average, and both your center line and upper and lower control limits for your moving range always will be 1.128 and 3.68 and 0. These values will be always common when you are drawing a ZMR or ZMR chart. So your center line UCL LCL for your Z chart and Z score values chart, and for the moving range of Z score values chart will be 1.128, 3.686 and 0. These values will always be same because we are drawing chart not for the measured values but for the converted Z scores. So this is the explanation that I want to give to this particular chart, friends. Now we will move on to the actual data and try to draw this chart. So for your convenience, what I'm going to do is I'm going to delete all the pre-calculated values and then we will plot this chart one by one. First we will plot it in Minitab, then we will come back to Excel. Okay, so what I'll do is I'll delete all these formulas so that it becomes easy for us to understand. Now what we have the stamping data for part number 1, part number 2 and part number 3. So these are short production runs and we are going to calculate chart for all these three different parts. Definitely their thicknesses are going to be different, it's not going to be same, but we are going to plot them in the same chart. So let me copy this data, take it to my Minitab, paste it in my Minitab. So my measurable value is here, my run number, so part numbers are here. So now I need to draw the Z chart. So I click on stats, I click on control charts. In control charts I select control chart for individual data and here I select ZMR, monitor the mean and the variation, that is moving average of different parts when relatively few units are made for each part as in short production run. So as I was explaining, in a same machine maybe for 1 hour, 30 minutes, 40 minutes I keep on change the setting and do different kinds of production. So short production run I select ZMR. So stamping data will be my variable data and production run information is taken from run number. And now I can go to ZMR options. So what I can do is I can say store my plotted data, show my center values, show my control limits. So I can put a tick mark on all these three. even I can say store my mean, standard deviation, test results. I can put a tick mark on all this and then I can say okay. The benefit of that is if we draw a chart, we will be able to get the chart and we'll also be able to get the corresponding values so that we can check whether these values are correct when we do it in Excel. So if you see here, the standard deviation, all the information are being plotted here, and here is the chart. So what we will do is we'll copy this chart. We will keep this chart somewhere here so that it becomes easy for us to compare. Now the interpretation of the chart, let's quickly interpret this chart, then we will move to the Excel calculation. So as you see here, the center line is 0, the UCL and LCL is 3, and for all the individual produced data points, the values are converted into corresponding standardized data because the corresponding Z scores are calculated and the chart is plotted only for the Z score. And similarly for the moving range, it is the difference between the consecutive Z scores, and that is why this value is missing. In this example, our production is well within the statistical stability. It is not going beyond any statistical stability. So this is how we can draw the ZMR chart in Minitab. Now we will come to Excel and see how the same can be done in Excel. So in Excel, the first thing that we have to do is we have to convert the absolute data points into its Z score. So as we see here, what we need to do is we need to first calculate the average for the first production run. So what we do, we take average formula and we take for the first 10 data points. Similarly, we say is equal to average we take it for the next 10 data points because this is second production run. And then we calculate average for the third production run. So these are average for 3 production runs individually calculated. Now I have to calculate moving range, and we all know for a data which is collected one after the other, the moving range will be is equal to absolute value of this value minus this value, and we cannot have a moving range for the first data point because there is no data point above. So we copy this and we paste it for part number 1. Same formula for part number 2 starting from the second data point, and same formula for part number 3 starting from the second data point. Now what we do, we need to calculate the R bar. R bar is nothing but average of moving range. So for average of moving range is equal to average, and I can select these data points, and similarly I can say is equal to average and select these data points, and here I can say is equal to average and I can select these data points. Now I have calculated each production run wise its X bar and its average. From this, if I want, sorry, X bar and its range and range average. So from this, what I have to do, I have to do the standard deviation. So standard deviation formula is R bar by D2. So R bar divided by the D2 value with n is equal to 2. So the D2 value with n is equal to 2 because individual data points. So hence I am taking 2. So I freeze this formula. So this becomes the standard deviation for the first production run. This becomes the standard deviation for the second production run, and this becomes the standard deviation for the third production run. So what I have calculated individual X bar, R bar, that is moving range average. R bar is here nothing but moving range average, and R bar by D2 is my standard deviation. This I have calculated for individual production runs. Now what I have to do, I have to calculate the corresponding Z value. So we all know Z value formula goes like this: the actual value minus the x bar. So I'm going to freeze this x bar so that I can copy paste the formula, divided by the corresponding standard deviation, divided by the corresponding standard deviation. Again, I'm going to freeze this so that I will be able to copy paste the formula. Now this is the z score for my individual values. These are individual values. These are the corresponding z scores. So similarly here I would say this value minus this value let me freeze this, divided by the corresponding standard deviation. Let me freeze this also. I copy this. So as I was explaining in the beginning of this video, if you see this carefully, even though these values are not comparable for production run and production run 1 and 2, the corresponding z values are comparable. That is the crux of this entire control chart. So absolute value minus the production run 3 average, and I freeze the formula, divided by the standard deviation. Again I freeze this formula, I can copy paste this formula now. Okay, so here I got the z values. Now I need to have the absolute moving range of z values. So I copy paste the same formula because I will be able to get the absolute value of this value minus this value. I can now copy paste it up to this point. Same formula, I can copy paste it from here up to this point, because for the first data point we are not going to calculate for that production run. That is the first unit, so I can copy paste it from here to here. And friends, as I told in the beginning, if you see this r bar, for any value of r bar, if you calculate its average, it will be 1.128. so this average, because we are calculating it for the standardized value, the r bar average will always be 1.128 irrespective of any data point. So that is why in the beginning of the video I explained the average of r bar will always be 1.128, the center line will be always 0, and the upper control limit will be d3 times of 1.128. so let's come here. Here I have the USL LSL values. So this is the z value. So z average will always be 0, z UCL will always be plus 3, z LCL will always be minus 3, z average will always be the standard value that you see here, which is 1.128, 1.128. Z UCL will be z average multiplied by d4 times. So the d4 value is here, so let's freeze it here. So the d4 value is here, which will be always 3.628, and moving range average will be 1.128 multiplied by d3 value. So this is the standard values. So I say is equal to, now this will be your corresponding center line and control limits for your graph. So if we copy paste this, and then if we take the z value alone, and try to draw the chart, you will get your z control chart. So just for our understanding, let me copy and paste it here so that it becomes easy for us to compare. So this is the Z chart for production line, and if I want to bifabricate this into production line 1, 2, 3, I can do it. Okay, that's one. The second thing is the R chart. So I can select the R value, and I can select the R value. I can select these values. Then I can click on insert graph. This I'll be able to get the corresponding R chart also. Let me paste it here so it becomes easy for us to compare the charts. So friends, let me quickly do a recap. So ZMR or ZMR is a chart drawn for continuous data, but trying to draw a single chart for short production runs of different characteristics, different product characteristics. As I was explaining here, the thickness of 3 different parts and they are not same. And how do we do it? We convert the absolute data point into their corresponding z-score values using the formula x minus x bar divided by standard deviation. And once the z-score values are calculated, for z-score values we draw this chart. So this is a unique chart drawn for continuous data where data is collected in the form of one after the other, not in the form of subgroup. However, it is collected from different short production runs. I hope this video was useful for you to compare the difference between IMR chart and ZMR chart, and where exactly ZMR chart will be used, and what is the formula to calculate Z score, individual Z scores, center line, and upper and lower control limit for Z chart, and similarly R values and upper and lower control limit and center line for R chart. Thanks for your time. Thanks for watching this video. For more video on control charts, Lean Six Sigma tools and techniques, Minitab tutorials, please subscribe to our channel. Thank you very much.